All right, so this is section 1.2. We're going to be solving quadratic equations. So generally a quadratic equation is an x squared term. So your highest exponent, your highest degree is a 2. So this is the second power. It comes quadratic from a square. We call this x squared, and a square has 4 sides. So that's why we call it quadratic. There are 3 methods to solving quadratics. Factoring, which is the fastest way, completing the square, and the quadratic formula. You need to learn all 3, and we'll be doing each of them in this section. So this first one wants us to factor. There are several ways to factor. I do mine a little different, and if you have a hard time following this, then in class we can look at another way. But I'll try to leave you guys a list of steps and show you what's going on. But once you do it enough, it becomes second nature, and it's really easy. So x squared minus 8x minus 48. Now I also want to make a note that this method that I'm about to use will work anytime that the problem factors, no matter what the problem looks like. So even if you have a number out front, let's just say 5x squared, and then you have, something x plus 8. Okay, this process will still work. And it also works when you have other numbers other than squared. If you have 3 terms here, as long as this middle term, the power, which is understood to be a 1 right now, as long as this power is half of this power. So that means I could have an x to the 6th power, and then plus something x to the 3rd power, and then just the number here, 10. If this problem would factor, this same process will work. Okay, so let's go ahead and get to that. So the first thing you do is you make sure the leading term is positive. This has to be positive, and it is. And if that's the case, then we will try to make this smaller. Like if we can reduce anything, if all of these terms have something in common, 1, 8, and 48, which they don't, we can only divide by 1, and 1 will not change the problem. So check this positive, reduce if you can, and then we start the factoring process. So you multiply your first number, the number out front, with the x squared, if it's in order, times the last number. Don't worry about the sign right now. So we're going to do 1 times 48. It works the same way if you have another number out front. So doing that will give me 48. All right. Then I am going to list the factors of 48. So everything that multiplies to give me 48. So that would be 1 and 48, 2 and 24, 3 times 16, 4 times 12, and then 6 times 8. So as you go down the list, I always start with 1 in itself, and the numbers get closer and closer together. So when they get really close, you're probably getting to the end of your list. So 6 and 48 is the last one. Well, how do we know which of these numbers that we use? You go to this sign. So this sign is a negative. That means you want to subtract these pairings. And you want to know which of these equal the middle number. So we use the first, the last. Now we're trying to figure out the middle number. So we have to subtract whatever this sign is, tells us what to do, the one at the back. So if it was positive, that means we would have to add. But since it's negative, we subtract. And we want to know which of these subtract to give us 8. Well, that would be 4 and 12. If you do 12 minus 4, you get 8. All right, so these are the numbers we use. If you find those numbers according to whatever this sign says, and it equals this middle term, it will always factor. All right, so that being the case, we are going to take this x squared, whatever it is, and half it. Or we're going to split it up. We're going to do 2 sets of parentheses. And then I'm going to put an x in each one. So that's x times x. That's my x squared. So if it was like x to the 3rd, you put x to the 3rd, x to the 3rd. 3 plus 3 gives you 6. So the same process. Then you add these numbers at the back, 4 and 12. And it doesn't matter which parentheses you put them in, it's going to work out the same. Order doesn't matter. Now we got to figure out the sign. So there's a couple things you can do. You can just kind of use your math intuition and figure out, okay, if I want to make a -8 when I combine these, which one needs to be negative, which one needs to be positive, etc. The way I do it is the first sign going from left to right here is always the bigger number. Bigger number out of the 4 and 12. 12 is bigger, so it's going to get a minus. The second sign in your original problem going left to right, this one, not this one, this sign. If it's positive, if it was a positive, you can't see that, I'm writing the plus sign up there. If it's positive, that means they're going to be the same sign. So that means if this right here was positive, both of these would have the same sign. So they would both be negative because you get the first one for free. So once you get this one and you look at the second one, they're either going to be the same or different. So negative, since the second sign is negative, that means different. So the signs are going to be different. So if this one is negative and they have to be different, that means this one has to be positive. Okay, once you do that, you are done. This problem is factored. Okay, so it's a little bit of steps, but if you go through them one at a time, it's really not that bad. I like doing it this way. It takes out guesswork. There's a little bit of a difference we'll talk about if we have a leading coefficient, but for the most part, this process is going to remain the same. So the factored expression is x plus 4 and then x minus 12. Now, if you already know how to factor and you do it a different way, then do that way. You don't have to do this way. But if you don't know how to and you don't remember, then feel free to use this. And if this is not working, let me know and I will try to show another way.